Welcome all of you. Webinar series of Power Electronics, video number 4. In this video, you will going to learn about construction of the silicon control rectifier. Okay, so silicon control rectifier. When you have see about that one symbol of the silicon control rectifier. This is symbol of the silicon control rectifier. So it consists of how many number of terminals? 1, 2, 3. What are the 3 terminals? Anode, cathode, gate terminals. There are 3 terminals. So where is a cathode? Cathode is located near to the gate terminal. Gate is located near to the cathode terminal. Okay, why gate terminal is located near to the gate terminal means gate terminal is located near to the cathode terminal means just you can look the construction of the 2 points. So it's you have look the construction. It is PN. There are 4 layer. It is a combination of the 4 layer PN. So like the 4 layer is combined. Okay, another one is how many junction is there? Mean there are 3 junctions. So like it is a 4 layer 3 junction devices. So how this 4 layer is formed? How this 4 layer is formed means it is formed. Okay, it is from the transistor formed from the transistors. You have look this diagram, the transistor connection, PNP transistor and NPN transistor. So this is like that one, this is a connected. So this is N and P and P is like you have connected. Then what is the total view it will going to come? So PN. This is a 4 layer. PN. So where is the P is connected? P is connected to the gate terminals. Okay, the top of the P is connected to the anode terminals. Then bottom of the N is connected to the cathode terminals. So like the 2 transistor, here is a diagram. So 2 transistor is it will going to connected. So it will going to connected to, you will going to frame the thyristors. So the thyristor is consist of the 4 layer PN junction, PN junction of the 4 layer and the 3 junction. So what are the 3 junction? Here you can look it. This is a junction number 1. This is a junction number 2. This is a junction number 3. There are 3 junction of that formed about that one. How many number of terminals? 3 terminals of that device. The next one you have see about that one construction diagram of that ones. So this is a construction diagrams. Okay, it is as usual I said about that last video. It is a unidirectional device. So it is a current is a flow from anode to cathode. It is a unidirectional current flow, and then it is a current controlled device. Current controlled device means you will going to apply for the gate with respect to the cathode. You will going to apply the current. Okay, you will going to control. So we'll go to forthcoming slide. We'll going to see about the static characteristics. So this is a static characteristics diagrams. When you have just to look at it, here is the thyristor is there, thyristor, or you can call it as an SCR, anode, cathode and gate terminals. So how the gate terminal is connected? Gate is connected. Okay, so it is connected through one of the variable resistance to the DC source. To the cathode is connected. So this is a source. What is the purpose of this source? This source it is used to, you will going to trigger the SCR. It is called triggering circuits. Here what is a type of method is used? R type of the method is used. So it is called R triggering. What is a type of the triggering? Resistance type of triggering. So that's why it is called as an R triggering. What is the purpose of the variable resistance is used? The variable resistance it is used to, you will going to vary. So slowly you will going to vary from 0 to, you will going to slowly, here you can see that one, slowly I will going to vary that gate current. When I will going to reach the gate current, okay, it is 0. So when I will going to reach the gate current 0, 0.1, 0.2, 0.3, for example latching current okay, 0.5. So 0.5 okay milliamperes, it is a latching current. So for turn on the current 0.5 milliamperes. So I will going to vary 0.1, 0.2, 0.3, 0.4. So once it is a 0.45, 46, 47, 48, okay, 49, 0.5. Once reach the 0.5 milliamperes, immediately the SCR is what will happen. It is the device. It is a turn on. Turn on means whatever you will going to flow the current from anode to cathode. It is a permitting. So it will going to permit from anode to cathode flow of the currents. So immediately it is increase the anode current. So before the anode current is not permitted. So when I will going to apply 0.45 gate terminals, so that SCR is not permitted. So once I will going to apply 0.5 milliampere, okay, the 0.5 milliamperes I will going to apply. So immediately the SCR is on. Once it is on means, so what will happen? The power is a flow anode to cathode. That's all. So this is a method. This is a method about the triggering method. This is a resistance triggering method. Resistance triggering method. The resistance triggering, it has the one limitation is there. So heat is the dissipation is another side. Okay, the limitation is there. It can't to vary from them. Okay, 0 to 180 degree. You can't to vary. So that is a limitation. That's why you can go for that RC triggering method. So RC triggering, it is used to, you will going to vary from 0 to 180. So that one you will going to see detailedly in the triggering circuits. Okay, this is one of the triggering method. Coming to the point here. Okay, so 0.5 I will going to apply it with help of that source and then variable resistance to vary. So if I will going to vary, suddenly suppose I will going to apply the 0.5 directly, what will happen? Immediately it will going to turn on. Immediately it will going to turn on. Suppose I will going to apply the gate current, it is a minimum current is a 0.5 I told. I will going to apply the gate current of that one 0.6. What will happen? Immediately it will going to turn on. Suppose I will going to apply the 1. So 1 milliamps, it will going to turn on that in that microseconds. So 2. So very fast it will going to turn on. So that like it is going to turn on. Once it is a gate terminal is turn on, so this circuit is idle. So idle means it is not using totally. You will going to remove. Just it is even you will going to remove. Even you will going to switch off that one this source. What will just you will going to check it in the laboratory. It will going to keep on conduction. So this is a method for that uncontrolled off. So even once it is a 0.5 is reached, after that you will going to switch off this ones. Another one you can remove for that this resistance as well as source you will going to remove. But the device is not removed. That is about that SCR. Okay, once it is over, then this is load. Okay, so load is connected in series with the anode. Okay, another one is I will going to connect it with the power supply, and then cathode it is connected to the power supply. So I will going to just it is a, so it is a, what is just it is what is that ones. Okay, you will going to connect it for that one power supply, AC supply. You will going to connect it to that one lamp, induction lamp, through the SCR. Through the SCR you will going to do. So you will going to, for example, the modern days, what you will going to do, the IoT Internet of Things, okay, or a remote control, it is used to on and off. You will going to on and off. So here is a relay system. It will going to use okay, once you will going to, when you want to trigger, so that one once you will going to decided, and based on that one in your remote you will going to on means, so the it's a AC power supply or the DC power supply, whatever your width of the power supply you have connected to, it will going to connect it to that load to close the circuit. Okay, so this is about the static characteristics diagrams. So here is you can look about this static characteristics diagram. It is very important one. You have seen this characteristics diagram. This is static characteristics diagrams. So x-axis and y-axis. So y-axis is a current. What is a current? Anode current. Where is a gate current? That is a gate current. So here is a gate current. So when I will going to apply the 0 gate current or a 0.1 gate current or 0.2 gate current or 0.3 gate current or 0.4 gate current. Okay, when I will going to apply the 0.5 gate current, the current is moved from here to directly straight lines. So this is about that gate current variations. So here is a 0. So it is a okay. Next one is a G1 is a 0.1, 0.2, 0.3, 0.4, and then 0.5. So like it will go to the variation. If you want to see means slowly can vary. Otherwise suddenly you want to on means you will go to on. Okay, you have see that one the characteristics diagram. From this point origin to up to this point, what will happen? It is called a VBO. Okay, VO means forward breakover voltage. During the forward breakover voltage, does SCR is conducted? No. So okay, from 0 to forward breakover voltage, that is the meaning of what is that one, 0.1, 0.2, 0.3, 0.4. Does SCR is conducted? No. So it is called forward breakover voltage. So when it is a cross the forward breakover voltage, so when it is a cross then the forward breakover voltage, you have to see that one, this is a point is called latching current. The dotted line is mentioned when it is a cross the forward breakover voltage, so forward breakover voltage, so it is reach the latching current, it is start to conduct. This is a 2 point. One is what is a forward breakover voltage. During the forward breakover voltage, the SCR is a turn off. Okay, when it is a cross the forward breakover voltage, you mean the SCR is goes to the conduction mode. This is the operation of the SCR. So what is that one? First point, forward breakover voltage. Then second one is a forward conduction. This is, you have written the line, forward conduction line, conduction mode. What is a forward conduction mode? Okay, that one is a crossed the breakover voltage, crossed in the breakover voltage. Once it will going to cross the breakover voltage, the SCR is a conduction mode. So in that quadrant, what about that one? Anode is a positive with respect to the cathode. Anode is a positive with respect to cathode. Okay. So here you have see that one small leakage current also there, small forward leakage current. Yes, it is written as a forward leakage current. Similarly here reverse side also small reverse leakage current also there, small reverse leakage current. Okay, now anode is negative. Anode is a negative with respect to the cathode. Anode is a negative with respect to the cathode. When you will going to apply the anode is negative with respect to the cathode, you will going to draw the VI characteristics of that ones. So what will happen? So it will going to start to flow on the reverse directions. This is the forced commutation method also. So you can say about that one. Okay. Okay, you have see that once it will going to start to conduct on the reverse direction. It will going to start to conduct on the reverse direction. So reverse leakage current it will going to happen. It will going to produce, and after that BBR. What is a BR? Reverse breakover voltage. It will going to cross the reverse breakover voltage. Reverse breakover voltage it will going to cross. Okay, but if you are going to keep on apply for that reverse breakover voltage, just it will going to cross the above breakover voltage. Okay, what about the condition? The current is increased. The current is anode current is increased in reverse direction. Anode current is increased. Due to the reverse direction, the anode current is increased, means more heat is produced. Due to the more heat, what will happen? The thyristor will going to quickly it will going to reduce their life. It will going to burn out. So this is about that operation, or you can say about working of that thyristors. So forward breakover voltage, forward conduction mode, and then reverse breakover voltage, reverse conduction mode. Then next one, you have see the same diagrams in that one. I have show you. Okay, in practically you will going to do like that once. This is a get triggering method. Another one is you will going to conduct a test on that once. So this is a left hand side. The variable resistance it is used to. You will going to set the 0.5 milliampere or 0.6 milliampere or 0.7 milliampere or 0.9 milliampere. Like you will going to vary the, or what about the gate current? You will going to vary the gate currents. Once the gate current is very okay, so you will going to variation of that one. Once I will going to fix the gate current 0.6 milliamperes, and after that what you want to do? So after that, in this is a side is a voltage is there, so I will going to use the fixed voltage or variable voltage. Suppose I will going to use the fixed voltage, then this variable resistance I will going to vary this variable resistance. Now it will going to conduction mode, so I will going to vary the resistance, take down the different readings of that current and the voltage. So note down this is a value. So this is a V, okay, AK across anode to cathode. This is the anode current. You will going to note down on that once. Okay, then next one more here you can look at one more tabulation I have show you. What is the tabulation? VAK means here. So now it is coming to that normal. Okay, you mean ideal, I mean zero conditions. So now I will going to apply that VAK voltage. So without apply the gate terminal, so I will going to increase the VAK voltage, 10 voltage or 5 voltage, 9 voltage. So whatever I will going to set the voltage. Does the SCR is conducted? No. Thus the SCR is conducted. I will going to vary this one to, I will going to set the 10 voltage, that is called VAK, anode to cathode voltage. Okay, in through this ammeter I will going to set it on that ones. Okay, does this SCR is conducted means no. Why the SCR is not conducted means you are not to trigger the SCR. This is called controlling circuit. This is called a controlling circuit or triggering circuit, or you can say about that firing circuits, whatever you can say that ones. Okay, this is a major, this is a controlling the part. Okay, in power electronics it is the controlling part, this is a power part. Okay, in the controlling circuits. Okay, so once I will going to apply the 10 voltage on right hand sides, okay, even it is not conducted, then later what I will going to do, this is a voltage and current value. So slowly when I will going to rise means quickly I will going to reach on that once. Okay, conduction mode. So take down the readings. So take down the readings. So slowly, so you will going to vary means it will quickly latching current, it will going to reach the latching current and a conduction about the latching current. So that is about the tabulations. You can fill the tabulations. So okay, VGK and the IG of that values. The next one, okay, so the okay, SCR operation wise you have say about that there are two type of the method. Okay, generally you can classify are modes by, you can say modes of that one. There are two modes. One is a forward bias mode and then reverse bias mode. What is a forward bias mode? This is a quarter number 1 is a forward bias mode. What about the quarter number 3? This is called a reverse bias mode. What about the what is the quarter number 1? Anode is a positive with respect to, here is a anode is a positive with respect to cathode. That is a forward bias mode. What about that reverse bias mode? Cathode is a positive with respect to anode. Cathode is a positive with respect to anode. When you will going to apply mean, that is called a reverse bias mode. Then operation wise it will go to forward blocking mode. What is a forward blocking mode? So this is a breakover voltage, this is a mode, okay, 0 to VBO, that is called a forward blocking mode. During the forward blocking mode the SCR is a turn off. So above the breakover voltage what will happen? Forward, it is moved to the forward conduction mode. Similarly reverse reverse blocking mode. So reverse blocking mode means from origin to that up to reverse breakover voltage, that is called a reverse blocking mode. During the reverse blocking mode also the SCR in reverse direction it is not conducted, few leakage current it will going to take place, and once it is crossed the breakover voltage the SCR is triggered, it will move on that reverse conduction mode. That's all. This is about that 4 modes of that operations. And one more point you want to know, okay, forward conduction mode, what will happen in the construction wise? So here is J1, J2, J3 is there. So when you will go to forward conduction mode means anode is positive with respect to cathode. When you will going to apply that one, J1 and J3 is a forward bias, J2 is a reverse bias. So forward conduction mode means the SCR is a for conduction, not this is first one is a forward blocking mode. So forward blocking mode means SCR is not conducted. So but it is a anode is positive with respect to cathode is negative, but it is not a conductions. So here is a, okay, you will going to apply that one, J1 and J3 is forward bias, J2 is a reverse bias. Due to the reverse bias the thyristor is not trigger on. Why the thyristor is not trigger on means the J2 is a reverse bias. Then it is due to the blocking. So that blocking is a avalanche breakdown. So you will going to break down on that once. So how to you will going to break down? It is keep on increasing on that once. Okay. So here is a anode current. You will going to apply for that one. This side is you will going to increase. So what will happen due to that one? This side gate to cathode is increase. So it is the breakdown. It will going to reduce. So once it is reduced on that one, the current is a flow from anode to cathode. So in that one, VAK is greater than the breakover voltage. VAK is greater than the breakover voltage. So due to that one, the switch is closed. So now it's a it is moved to the conduction mode. The next one is a reverse blocking mode. What about the reverse blocking mode? Okay, here is a cathode is positive with respect to anode. So now is a J1 and J3. The junction J1 and J3 is a reverse bias and J2 is a forward bias. Just it is opposite. So here is a due to that one small leakage current it will going to produce. But in that mode also not conduct the SCR. then what will happen, you will going to keep on increasing on that one. So it will going to further, you will going to increase means the breakdown it will going to, okay, that reverse breakdown it will going to take place. Once the reverse breakdown is take place means the switch is closed, so reverse direction it will going to flow. Okay, due to the flow of that reverse direction, so what will happen, so heat it will going to dissipated. So it is a large amount of the heat is rise due to the more loss in SCR. So due to that heat, what will happen, the SCR life it is reduced, it will going to get quickly damaged. So that's all. So at the end of this video, what you have learned means, the first one is the SCR construction. The construction of SCR, there are four layer, PN layer. Okay, another one is it consists of that junction 3 junction J1 J2 J3. Another one is it is a 3 terminal anode cathode and a gate terminal, 3 terminals you have used on that one. How did the construction is made means, two transistor PNP and NPN, it is formed, it is connected to, you will going to develop it about that this SCR. So this is about the background about the construction. Next one you have see about the static characteristics. In the static characteristics means, so current versus the voltage, anode current in that y-axis, okay, anode current in that y-axis, and then x-axis is a voltage, anode voltage VAK, you can say about that one. So you will going to draw the characteristics. It has that 4 mode, okay, forward blocking mode, forward conduction mode. So when it is go under the forward conduction mode, so forward blocking to forward breakdown. So once breakover is over, so it is moved to the forward conduction. So the next one is a reverse breakover, another one is a reverse conduction. There are 4 modes of operation. That's all. Thank you.